Hi there, Mr. Sutton here, bringing you the IM374 Extra Practice #1 solutions on right triangle trigonometry applications. On this problem, we have a ladder leaning against a building. Top of the ladder is 18 feet above the ground. Foot of the ladder is 7 feet from the building. We want the measure of the angle which the ladder makes with the ground level. Well, we have a ladder leaning up, and we want the ground level angle, so we have a right side up triangle. Now, just putting in all our measurements here, we said that the ladder reached a point 18 feet above the ground. So that's this side of the triangle here. And then the foot of the ladder is 7 feet from the building. So here's the foot of the ladder. Here's the building. So 7 feet goes down there. And we want the angle between the ground and the ladder. So that's this angle here, the angle of elevation. To get that, we need a trig function, one of our SOHCAHTOA functions. We've got the side across from the angle, the opposite side. We also have the non-hypotenuse side that's touching the angle, so that's the adjacent side. Opposite and adjacent, that's TOA, the tangent function, which equals opposite over adjacent. So we can write tan of x equals our opposite side of 18 over the adjacent side of 7. And then to actually get x, we just need to do inverse tan of 18 over 7, which we will do on the calculator. So plugging that into my calculator, doing second tangent to get tan inverse, we end up with about 68.7 degrees if we round that off to the nearest tenth. In this action-packed problem, your fishing boat started to come loose from the dock. Oh no. You grabbed the line, though, before it got too far. Your dock's 40 inches above the water level. The line you're holding on to the end of is 10 yards long. We want the angle of depression to your boat at this instant. Well, whatever else we know, they said angle of depression, so we're going with an upside down right triangle, like so. So here is, let's see here, this must be the dock up here, and this must be your boat down here, and it looks a lot steeper than it probably is in real life, but this hypotenuse is your rope. And this top distance, that's how far it is from the dock to the boat, and this distance here is the distance, the vertical distance to the water level. So they said the dock is 40 inches above the water level. So that would be this vertical distance, 40 inches. And they said the line you're holding on to is 10 yards long. So that would be this side here. Now, before you just go ahead and write 10 in there, this is a tricky one because the units were different, right? They said the dock is 40 inches above the water level, but then they gave you a rope that's 10 yards long. So we need to convert this into inches if we want to keep our units consistent and actually be able to solve this problem using some trig. So how many inches is 10 yards? Well, first we have to convert to feet. So there's, let's see here, 3 feet in a yard, so that's 30 feet. And there's 12 inches in a foot. So 30 feet times 12 inches, that's going to be 360 inches. And now we wanted to find the angle of depression. That's this angle in the triangle between the horizontal and the hypotenuse. So I'll put an X there. So that is the setup for this one. Now let's look at the sides we have to see what flavor of SOHCAHTOA we need here. We've got the side across from the angle. That's our opposite side. And this 360 is on the hypotenuse of the triangle. So opposite hypotenuse, that's SO, the sine function, which equals opposite over hypotenuse. So we can write sine of x equals our opposite side of 40 divided by our hypotenuse of 360. And then to actually get x, we need to do sine inverse of 40 over 360, which we will go to the calculator for. So on the calculator, I just did second sine to get my sine inverse here, and then 40 divided by 60 inside, giving me about 6.4 if I round that off, and that's going to be degrees because this is an angle. On this problem, we've got a wire attached to the top of a pole, reaching a stake in the ground that's 20 feet from the foot of the pole. And we have an angle of 58 degrees with the ground. We want the length of the wire. So first, let's figure out which kind of triangle we're drawing here. Since this angle is talking about 58 degrees with the ground, if we're going between the floor and the wire, that's going to be a right side up right triangle, like so. So on the left here is the stake in the ground. Over here on the right, this is the pole sticking out of the ground. Now let's put some dimensions on here. We said that the pole reaches a stake in the ground that's 20 feet from the foot of the pole. So this is 20 feet between the stake and the pole, so we'll put a 20 down there, 20 feet. And they said that the angle is 58 degrees between the ground and the wire. So that's the angle of elevation between the horizontal and the hypotenuse, 58. And then finally, they want the length of the wire. Well, the wire is this hypotenuse here going from the stake to the pole. So that's x right there. So we're just finding x. Okay, well, we're looking for the hypotenuse. We have the non-hypotenuse leg of the angle, which is the adjacent side. Adjacent, hypotenuse, that's the ka part of SOHCAHTOA. So we need cosine. Cosine of theta equals adjacent over hypotenuse. So we can say cosine of our angle, 58 degrees, equals that adjacent side that we said was 20, divided by our hypotenuse of x. To solve for x, I have to multiply by x and then divide by cosine. So that's going to be 20 divided by cosine of 58 degrees, which we will go to the calculator for. So here we are on the calculator, 20 over cosine of 58, and that's going to be 37.7, and that's going to be in units of feet. So that's how long our wire is. For this problem, we're actually given this picture. We just want to find this horizontal distance h down here that these bleachers cover, and round to the nearest foot. All right, so since we've got a right triangle and we're looking for one side of it, and we have an angle that's not a special angle like 30, 45, or 60, we're going to go with SOHCAHTOA for this. In particular, we have the hypotenuse, and we're looking for the non-hypotenuse leg, so the adjacent side. Adjacent, hypotenuse, that's the ka part of SOHCAHTOA. So that's going to be cosine equals adjacent over hypotenuse. So we can write cosine of the angle they gave us, which was 27, equals the adjacent side, that's the h that we're looking for, divided by the hypotenuse of 18 that they gave us. So to get h, I multiply 18 by cosine of 27, which I'll do on the calculator now. So here we go on the calculator. 18 times cosine of 27 comes out to 16 and some change, but it rounds off to 16. They want it the nearest foot. So that's going to be about 16 feet. On this one, we have an observer in a 55-foot lighthouse spotting a ship in distress at an angle of depression of 9.5 degrees. We want to know how far the ship is from the shore. So this might actually be good to know. Well, angle of depression, we've got an upside-down right triangle. So here is your observer in the lighthouse at the top of this triangle, and down here is our ship in distress. So we've got a 55-foot tall lighthouse. Well, the lighthouse is over here, and it's 55 feet, but that's the same as this other side of the triangle that's vertical. So we're going to put the 55 over here just to put it somewhere on the triangle. And let's see, we have an angle of depression of 9.5 degrees. So that's between the horizontal and the hypotenuse for angles of depression. So the 9.5 goes right in there. And then we want to know how far the ship is from the shore. Well, here's the shore down here at the foot of the lighthouse. Here's the ship. So we want this distance here, which corresponds to this other distance in the triangle at the top. So this is our x up here, but it really is talking about this distance down here. So now to find x, looking at the sides that we don't have the hypotenuse. We have the side across from the angle, that's the opposite side, and the side that's touching the angle but not the hypotenuse, the adjacent side. Opposite, adjacent, that's the TOA part of SOHCAHTOA. So we need tan of theta equals opposite over adjacent. So we can write tan of our 9.5 angle of depression equals our opposite side of 55 divided by the adjacent side of x. And to get x, I have to multiply by x and divide by tan of 9.5. So 55 over tan of 9.5 now is what we're going to do on the calculator. So there we go. Plugging that in the calculator, we end up with 328.7 if we round that off. So that's how far away the ship is from the shore.